What's going on, folks? Can you folks see me online? Can you see me in class? Of course. Can you hear my voice? Can you hear my voice? Good. Can you? I love that. Can you hear my voice? There's like a delay effect. It's awesome. Anyway, today's class is going to be kind of a lab basic deal, right? And you folks will be sitting in here, and I've got some pretty, not junk attendance, because, the people here aren't junk. It's just poor. I don't know if you folks are poor either, but I'm just saying, like, not a whole lot of students showed up. What's the deal with that? All right, look, the reason why we're having Algebra Lab is not necessarily because we're going to do a full-on lab that has algebra in it and all of that kind of stuff, but it's because I wanted an opportunity to come in and interact with you and meet you, and it's so much easier for me as a teacher to like teach a topic and then look around and see everybody like this. Or like, oh yeah, I get it, right? So like that way I can kind of at least get an understanding. I understand this last minute, that's my fault. I should have probably emailed it out to you a lot earlier, and I apologize for not doing so. Anyway, what I'm going to do today is I'm going to do a couple demonstrations for math, and basically we're going to go into teaching about the Algebra 1 review, which is talking about linear functions. We're going back to lines, and we're going to really hit those equations. Because I've introduced to you graphs, I've introduced to you, different things. I don't think we covered parabolas too heavy. We're going to review that as part of the thing. My goal is to get through this huge packet today. Cool? And I think I'm going to start it off with this. I think this one's pretty cool. Let me show you, folks online. I got this kind of set up over here. I don't know if you can see it. Let's see. All right, so here's what we got. Do me a favor. Kobe, can you be my cameraman? All right, just hold the thing real stable like that. Perfect. Like that. Perfect. All right. So check this out. Here's what we got. We have a fishbowl of water, and we have a motion sensor, and that's hooked up to my computer. And then we have a giant fishbowl of water. What I'm going to do is I'm going to get the motion sensor, and we're going to measure the height at which this thing, or the distance, this like sonar bounces off the ground and comes back and hits it up back over here. Sound cool? And then what we're going to do is we're going to pour in water. But the reason why I have a higher fishbowl up here, I almost broke it, a higher fishbowl up here is because I'm going to siphon the water from here down into here. Why would I want to do that? You have no idea to the method behind my madness. Why would I want to siphon the water? Well, remember the problem that we did that had that? I'm doing this because of you, because you asked me, you were like, wait a second, why does it shape like that, right? And I'm saying, well, because we're talking about a problem where they were like filling up a container that looked like, basically looked like that, right? An ipu kind of deal. And it was, so I was talking about a circular bottom and that kind of stuff. And so I want to prove to you that I actually got the right graph. So what I'm going to do is I'm going to perform that experiment. The reason why I'm siphoning it is because I want the water to flow in at a constant rate. I don't want it to be like me pouring something in, because then it could be like filling up real quick and then, you see what I mean? So I want it to constantly be flowing in like a water hose or something like that. So I have a makeshift water hose that I just made. And it's made out of siphon. So anyway, and while I do that, I'm actually going to show you the data and then collect the data, and then we'll compare it. Because I think this is really awesome and exciting, and this is me trying to get my math to be more exciting for you. All right, this is me trying to do the song and dance for you. All right? So please be excited. Please don't be like, oh my gosh, I have to be here.
Bradley said, so chemistry didn't have a class today?
No, chemistry will have a class today. Chemistry class starts at 2:15. Algebra 2 class goes till 2:15, 2:10 or something like that. And yes, I will give you breaks. I'm not going to talk to you for like an hour and a half or whatever. Cool? All right, so check this out. Can they see this? Can they kind of see the graph? It's harder to see. You'll see it clearer, hopefully. All right.
Well, we can't see the chat.
She can see the chat. She's my chat box. All right. So here's what I'm doing. I'm going to set up a siphon right here. I'm going to. Do you guys know how a siphon works?
No.
Like scientifically? I'm going to. There we go. Into this one. There we go. You can siphon gas out of people's tanks by this technique too. Yeah, don't siphon gas because it's kind of toxic when you drink gas. So. Well, that's stupid.
Yeah.
All right. Anyway, hey, let's do this. And go. Whoa, that thing's filling up fast. All right. And start the graph. Where's my mouse? There it is. It's starting. And then you can't see anything except a red line. Can you guys see the red line?
Yes.
Okay. Let's do this. I'm going to scale this thing. Is it filling up? Doesn't look like it's doing anything, huh? No. The x-axis is the time. The y-axis is the height.
Okay, so
Wait, let me try something.
Oh.
Oh. Darn it. All right, here. Let's try it again. Okay. Stop the siphon. And stop the thing. All right, we need to time this. Okay, stop. All right, home. And no, I don't want to save it. Save work. I want to open this thing up. Linear graphs. Open that. All right. Kasia, I need you to come on this side. Press the button when I say go. Okay.
Wait, where's the button?
The button is just press the trackpad.
Wait, don't let me screw this up. Is it the play button? The
I
green
will
one?
try not to let you screw it up.
Is it the play button?
Yes, the play button.
This one.
Yeah, and then you're just gonna click the track. You know how to use a Mac.
We'll see.
All right, Lucas, come on over here and hold the thing so it's in the water.
The siphon?
Yeah, hold the siphon so it's in the water. Sometimes you can get a siphon started like this. No, but not apparently this side. No, you come on this side. Yeah, and see if I can get all 5 of these started up at one time.
So, what am I supposed to do?
All right, ready? Hold this.
This.
Yeah, just make sure it's in the water. Okay, ready?
Okay.
Set. And wait, not yet.
Oh, this is scary.
Okay, Kasia, go.
Oh, it's too much for me. Bye.
Oh, it's all over the place.
Oh, wait, it's too. There we go. Just wait for it. Just wait for it. I swear the graph was beautiful when I did it first time. And now it's junk. Actually, it's not that bad. Whoa! Alright, this isn't working. Okay, wait a second. Alright, take that out. We're doing it again.
Stop
I
it?
swear this is going to work.
Should I stop it?
Yeah, stop it. Alright. We're going to go with 1. I wanted to do 5 because I thought that would be more interesting. But we're only going to use 1 hose, and it might take a little bit of time, but I want it to work. I want to prove to you that I was right to begin with. You folks are like, man, Mr. Dalton, give it up. You were wrong, okay? All right, here we go. And no, I don't want to save that. I want to go to here to save work. Oh, wait, no, back. I want to go to here to save work right here. I want to open that. All right, click play when I say go. Okay, I'm only going to use one, so you don't need to worry. You can sit down with this one. All right, you ready? Set, go. All right, there we go. There we go. Okay. Might take a little bit of time, but I think it's going to work this time. All right, you can sit down, Acacia. What do they see? Is the graph linear? Do you think it's going to be a line?
I think it should be
Why?
because it's going in at a constant rate.
It is filling up at a constant rate. Yes, I agree. But I don't think it's going to be a line. I don't understand what the dip in that is. I wonder if it has something to do with like the water sloshing around like that. That'd be interesting.
Let's see.
All right, this thing is tripping me the heck out. Why does the graph look like that at all? What is going on?
The dip gets bigger.
It's confused.
Yeah, but why is it? Huh.
You said it was straight the first time you did it?
No, well, it didn't have this pattern like that.
So it was like completely straight?
Maybe like the line of best fit is actually right here.
All right, fine. Let's do the line of best fit on that thing. But that's crazy. That's crazy. Like, it wasn't looking like this before. Anyway, it's kind of giving me the shape that I want, though. Right?
Yeah.
You guys like now?
Oh, if I were, you mean the height of the?
Yeah.
Am I
Does
going down?
is this doing what I thought it would be doing? Heck no. I have no idea why it's doing this kind of like alternating up, down, up, down, up, down kind of thing. It looks like a zipper.
Is there like a setting for how it?
I imagine it has something to do with shooting it into a glass bowl. To be honest with you.
You did it with that one.
But I did it right before with one siphon and it worked. But it's giving me the line that I want. It kind of gives me the line that I want. Is it a linear? Is it a line?
I mean, it could be if it wasn't doing that pattern.
Yes.
No. Let's say we draw a line right through this thing right here. Is that a straight line?
Oh
Yeah.
yeah.
No.
Looks like
No. It doesn't even look like a straight line.
It's like curvy.
It's almost curve-ish, right? All right. Let's.
Why is it going down though if it's graphing the height?
I don't want to siphon all that water in there, or it's going to spill. Okay. So check this out. Because when I don't know what they can see, but maybe they can. Yeah. When I graph this for you, okay. When we were talking about filling up a bowl like this at a constant rate, I told you that it would look like this, right? I told you that it would look like the square root of a number or something like that. When in actuality, our graph kind of looks like this. And I would argue with you to say that, like, actually, my graph was the same as that because we just measured it differently, right? When I originally drew the picture, I was measuring height from here to here.
So
Does that make sense?
Is the height meaning the distance between height between the
Yeah, between the water and the
camera?
thing. So
Okay.
in our experiment, here's the camera right here, and it was measuring the height from here to here. So that's why the graph was inverted like that. But look! It's still the same curve that I predicted that it would be. Isn't that crazy cool? No, you guys are like, oh man, this experiment is kind of weird. I mean, don't you think it's kind of cool? Like, piquito cool? All right, let me show you something that I think will trip you out. Let's use this motion sensor again, and I wanna motivate for you linear graphs and line graphs. Can they see me in the camera? All right, cool. I want to motivate for you line graphs. Now, if I take something like this, I put the motion sensor on the ground, and I drop it like this. How's that graph going to look?
What's the x and y?
Okay, all right. question? All right, here's the setup. I have the camera. It's looking like that. Got it? I got a ball. I'm going to drop the ball on the camera, and it's going to give me, here's the height, here's the x. So over here, it's got a high height. And then, oh no, here's the time. So how's that graph going to look? Do you guys know?
Like a,
They kind of balance.
Like those.
and then
It will be a parabola.
yeah,
Are we cool?
half
Right.
around.
Why? Why is it a parabola? Half a parabola.
They'll keep
Objects
one.
increase in speed as it drops.
It increases speed as it drops. That we call that acceleration.
Acceleration.
Acceleration, which is caused by
Gravity.
gravity. Good, you guys know your fourth grade science, all right? Which is caused by gravity, and so it would cause this parabola, which is my motivation later on for showing you folks all the properties of parabolas. But I told you that I would want to show you something that is a straight line, because today's lesson is all about straight lines. Are we cool? Now, when I drop this thing, if I were to drop this thing from here, it will give me this parabola-looking thing. It's hard for you to see, and it was hard for the people who experimented on this originally to see, and that's why they thought everything fell within a straight line. Okay? But it doesn't. It falls in the velocity, or the height versus time graph makes a curve that we call a parabola. Are we cool with that?
Yes.
Now, if I took this to the Empire State Building and I dropped it, or maybe out of an airplane and I dropped it, will it keep on accelerating and accelerating and accelerating, and will the speed keep on going higher and higher and higher?
Terminal velocity.
Ah, you're using a big word right there. Terminal velocity. It's not even that big of a word. Have you heard of that word before?
Yeah.
What is that?
Isn't that the maximum speed that an object can fall?
Right, that's the maximum speed that some object can reach. The thing will speed up and speed up and speed up until a certain point where it's like, you know what? The amount of force that they, because, you know, I mean, if I jump out of an airplane, right, I'm going to be like, whoa, and it's gonna like that, right? I'm going to be falling out of an airplane. There's going to be wind pushing me back, right? Or air pushing me
Yeah.
against me. That's what makes my cheeks go like this. And then so what happens is that force pushing up will balance out with the weight of my body, and then I won't fall any faster. I'm just going to fall at a constant rate. That's your terminal velocity. Have you heard of this before? This is a little bit outside of math. We're talking a little bit of physics here, but I mean, this isn't too crazy of stuff.
Have you ever done that?
Have I ever jumped out of an airplane? No. And I'll tell you a story about why I did it, but at a later time. Did you know, because I have stories all the time, did you know that mice can survive a jump from their terminal velocity? Do you know what that means? That means you could throw a mouse out of the Empire State Building,
it's
and it will
alive.
fall, and it will reach its terminal velocity, and it hits the ground and just run away.
How?
That's terrifying.
I know, isn't that? You can't kill mice by throwing them out the window. Of course,
It's like cats.
if I were at the top of the Empire State Building or in a plane, I probably wouldn't throw it out the window to try to kill it. You know what I mean? But if you threw a mouse out of an airplane, it will fall.
Mouse.
hit the ground, and run away.
How?
Well, because would you disagree with me that long hair causes more drag?
Oh yeah.
So mice have lots of hair on their body. They also have very small weights. So when you balance out those two properties, they actually
Good.
create enough drag for themselves that they can survive their terminal velocity.
So it's low terminal.
Cats are very
velocity.
similar too. A cat could like be chasing a mouse out. A cat and a mouse could be chasing each other, fall out of a building, hit the ground, and continue chasing each other. Crazy.
So it's low terminal velocity. then?
Anyway, yes, I'm talking about reaching terminal velocity. Now, when we're talking about reaching terminal velocity, you were saying that that's the point where you don't speed up, you don't slow down. You just stay at a constant velocity, right? You know what else reaches its terminal velocity? All right, you need a volunteer. Sorry, what was your name? Shannon, you'll be my volunteer. Is that cool? All right.
You're voluntold.
Yeah. You're voluntold. Hey, that happens to me all the time. My wife just be like, hey, hon, I volunteered you for this thing. So you didn't volunteer me. you just kind of told me that I'm volunteered, right? All right, Shannon, come on up here. Shannon, can you stand on top of the chair? I want you to hold this thing. No, don't crush it.
Oh, I'm so sorry.
All right. You know, we'll get a new one. Don't worry about it. I got a bunch. Here we go. This is your average coffee filter. I think this is crazy cool. By the way, can you guys see Shannon online? All right, cool. Here's what we're going to do. Shannon, you take this thing. I want you to, here's the idea. This is a motion sensor, and it will sense how far that thing is away. I want you to just kind of take this thing right here, put it right above the thing. I want it to fall down and hit that thing. Don't worry, it's not going to break it. It's a coffee filter. Hold it up high, as high as you can. And drop it. Don't drop it now, but you're going to drop it, and it's going to fall and hit that thing. Cool? Hopefully, that's our goal. And hopefully what I can do is get a good graph as to the height versus time graph, because that's how I have this thing set up. We cool? You ready? In 3, 2, 1. Almost. All right, here we go. I'll tell you what, let me try that again. I'll give you another shot at it. All right, here we go. Saved work. This one. Can you grab the, here, I'll grab it. Oh, you got it all wet. It was all wet. It's my fault. All right. There we go. I'll use the other cotton filters to clean up the things. All right, here we go. You ready? 3, 2, 1. Perfect. All right. Let's take a look at this graph. You want to know what this graph looks like? It looks like that. All right. So this right here, thanks, Shannon. This right here is when she was holding it, right? This right here was when it was falling, right? This right here is what happened.
After it hit it.
Well, it hit the ground. It didn't actually land on this thing, and this thing's shooting up where? And saying, oh, hey, the distance right now is the roof, right? And there's nothing over it, right? So it's a constant. The roof didn't move, so. Oh, yes, I'm sorry. You're absolutely right. I forgot all about that. There we go. Can you see that now? Okay, so this right here is when she was holding it. Then she dropped it like this. And then it spikes up over here and gets this part over here. What is this right here? This right here. What is that? Well, that's a straight line. It's not a curve. I mean, it kind of is a curve to begin with, but then it's straight. It goes to a straight line pretty quickly, right? All right. That means this coffee filter reached terminal velocity almost instantly, and that's kind of. I mean, if you watch how this thing falls, it's pretty crazy. I can't get one. Hold on. I think it's cool. Okay. I'm going to get one from the middle for some reason. All right, here we go. Now, I apologize for those of you who aren't online, but you won't see this. But that's too bad. Here, let me just show you what it actually looks like when it falls. Excuse me, Asia. Here we go. Drop it. I think it looks cool when you watch it. It falls at a constant speed. Isn't that crazy? I don't know. Mrs. Baldwin always gets excited about things. You guys are like, oh, okay. All right, fine. I'll tell you what. I'll make an app out of it, and then maybe that will excite you or something. You could do it on your cell phone or whatever. All right. But this thing falls at a constant speed. And if I figured out the slope of this line, which is the rise over run, what would that tell me? This is the position versus time graph. If I figured out the slope, what would that tell me? Those of you online, please answer. What? What is it? The rate at which it falls, which is also called the acceleration. No. If it has an acceleration, it would be a curve. Starts with an S. Speed. It's speed. Yeah, I was expecting you to tell me when somebody online would say something. Yeah, the speed. If you find the slope of this thing, you would get the speed. That's important information, right? That would be useful to know. So that's my motivation for you, for us doing this whole chapter on lines. And keep in mind, I'm going to go through this thing pretty quickly because I'm assuming you've seen y equals mx plus b before, right? Like this is not going to be tough stuff for you today. All right, good. Today's going to be y equals mx plus b. And I'll go through as much things as I possibly can off the top of my head about cool things about it. And I'm not even required to do like a math lab, but I figured that this would be an interesting way of kind of motivating this idea of a lab for you folks. Cool? All right. Shannon, can you do me a favor? Come on up here. There's a spot for you. I'm going to hit the whiteboard. Get out your pencils and papers. Let's start taking some notes and going through this chapter. All right. What is a linear function? Straight line. A linear function means line. Very good. It's any graph that is that has a line as a property. Cool. What do you folks know about? What do you folks know about lines? I'm just going to start it off like that. What do you folks know about lines? They're straight. What about? I mean, is there an equation you know about lines? So let's go to y equals what? The slope. What about the slope? Tell me about the slope. If you know about the slope.
It's rise over run.
Slope is rise over run.
And
Do you folks remember the equation for rise over run?
y2 minus y1 divided by x2 minus x1.
Just a second. I'm so sorry. Hello? Hello? Yeah. No, just send him up there. Yeah.
It's okay.
No, send him up there.
Are you
All right. That's right. Rise over run. Slope is equal to rise over run. What is the equation for that? Do you guys remember?
y2 minus y1 minus, divided by x2 minus x1.
And I covered in the lecture how to remember that. Do you guys remember that? No? Okay, all right, here. This is where it comes from. I'm not going to pull it out, throw it up on the board and say memorize this. I want you to know where this comes from. Essentially, I want you to understand this concept. Here's where it comes from. You got a graph.
Oh yeah, I remember.
Let's pretend that I have 2 points. I've got x1 and y1 as this point right here. And I've got x2 comma y2 as this point right here. And I want to talk about how high something went divided by how far across something went. How high did this go? If I start here and I end here, what's my difference in height? What? There are coordinates. This is x1, y1, this is x2, y2. Well, who says you need numbers? There are coordinates right on the board for you. All right. If this were a number, right, and if I did give you a number, then how would you figure out the difference in height?
y2 minus 1.
You would just subtract whatever that number is minus that number. So that's what I was asking you for. y2 minus y1. y2 doesn't equal y1. It's got to be y2 minus y1.
Oh, yeah.
All right, cool. All right. What about the horizontal distance that it went across?
x2 minus x1.
x2 minus x1. Awesome. So that's why rise over run is y2 minus y1 over x2 minus x1. Are we cool with that? Awesome. So that's to find the slope. Now, they did a few things over here. Let's see. I'm going to skip. Do you guys feel like you're really comfortable with getting slopes?
Yeah.
All right. I'm going to do it this way. Here we go. Let's draw a few graphs up here. This will be a graph of line Tx. This is Px. And this is Hx. Which one has the biggest slope? It would be Tx. Why? Or how come?
The steepest.
It's the steepest, right? It's the hill that I would not want to walk up the most, right? If this represented the different prices of nuts for, I don't know, pounds, right? You have pounds over here versus the amount you would pay, then this is, I don't know, like this is pistachios, and I don't know what kind of nut starts with a T, and this would be, this is Tasmanian nuts, and this is nuts from Haiti. How's that? Which is the most expensive? What is that? The TX. Awesome. Man, that was an easy question. Excuse me. All right, here we go. Let's graph this one. I want to see what your brains are like with this one. Say that this is X and Y. And I want to graph a slope of m equals 1. Can you give me that graph? What does that graph look like? Anyone? Yeah, come on up. Just draw. You can use a different color if you want. Thanks, Willa. Yeah. I'm just looking for a ballpark. I'm not looking for exactly. All right, perfect.
Sure I know.
So draw a line. There we go. Awesome.
Yeah.
Awesome. Let's make it harder. What would a slope of 2 look like?
Just a little more steeper.
It would be the same kind of deal, just a little bit more steeper. Is that what you're saying? All right. Something like that, maybe. For every 1 across it goes 2 up. Is that what you're saying? Or maybe for every 2 up it goes 1 across. We cool with that?
Yeah.
All right. What would a slope of 10 look like?
Like that.
It would look kind of like this.
That's where 10 is in the
All right. What would a slope of like 1,000,000 look like?
A million and then 1.
Would it be so steep it would actually go backwards like that?
No.
No.
Okay. It would be kind of closer to like almost 90 degrees.
Yeah.
Good. All right. Just making sure you folks know what you're doing. All right. So it would be kind of like almost vertical. Can I ever make it just vertical, straight up vertical?
It would be
0.
Can I ever make a vertical line? Like, can I make the slope so steep that my line is perfectly vertical?
No.
Yeah, it's the undefined one, right?
No, Sophia's kind of got it. It's an infinite slope. But actually, there's no such thing as an infinite slope. And in fact, if you think about it, if your graph was a vertical line, it doesn't pass the vertical line test, right? Because your vertical line test would be like, bing, 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 bing. There's a lot of points that touch this vertical line. Does that make sense? If at any point your graph goes so steep that it's vertical, then it doesn't pass the vertical line test. You got a problem.
It's so weird. Like,
Does that make sense?
if your line is almost vertical, it's still a function.
Yes, if your line is almost vertical, if it has a slope of 1 billion, it is still a function. It's a very steep function, but it's a function. Now, if it has a slope that is vertical, that doesn't exist because your slope would have to be infinity,
So
then it doesn't pass the vertical line test. What is that?
Would it be 0 or non-existent?
It would be does not exist. DNS. DNE.
So it's undefined.
Undefined. Undefined does not exist. Why are you asking me this crazy question? That's what it would be. Cool? Awesome.
Yeah, that's what
Oh,
I remember.
I want to graph some more. What would a graph of, what would this graph look like? Or what would this slope be? Someone online, you can answer me. What would that slope be? If this were the graph of 1, what is that? What did you say?
Yeah, I think
0.5. Very good. I love it.
Yeah.
So it can't be slope is 1, but it has to be slope is like a fraction. We cool? All right. What would this slope be?
Pia says she couldn't see.
What would that slope be? It'd be -1, right? Because it looks like it's just kind of. Are we cool with this? This is like familiar stuff with you. So if it's bigger than 1, then it's above this line. If it's smaller than 1, it's below this line. And then if you want to go into this territory, then you have to put a negative in front of it. If it's negative a fraction, then it's like around here. If it's negative like a big number, like anything bigger than 1, then it's over here. We cool with that?
Yes.
Awesome. You guys are masters of slopes then. Let's move on. See, I told you I'm burning through this stuff. All right, let's see. Slope 2 past, okay. I don't want to have you guys graph these things. I'll tell you what, take out your papers. I'm actually going to start doing some homework with you. And I don't think I posted this homework yet, so I'm covering stuff from into the future. All right, let's see. If we have something like 30, -10, 40, 15, 50, 60, and 60, 65. There's an x, and here's a g of x. All right. What's the slope? How do I find that? Do you know?
Graph it. X, Y.
You would graph it? That's what you would do?
You would use the slope of formula.
You would use the slope formula? That's what you would
Yeah,
do?
with the 2 points.
I'll be honest with you. All right. Graphing it kind of sucks. But I hate using that formula because I always get screwed up. Don't you get screwed up? So what I like to do, and I'm just telling you this from my personal experience. What I like to do is I actually do like to graph it. That's not that bad of an idea. And at least I would kind of do a kind of a hybrid. And the reason why I'm telling you this is because sometimes when I take an SAT or something like that, I get screwed up. And I forget the formula. I forget how to write down that formula correctly. So what I would do is I would kind of just do an ugly graph. Like, let's just choose 2 points, okay? And we'll go 10, 20, 30, 40, 50. Because these are my 10s. So here's 40,
And you're almost
here's 50.
equals to 10, so.
And then this one right here is, let's go 10, 40, or 10, 20, 30, 40, 50, 60. All right. So I would do something like at 40, comma 15. So I would draw a point right here. And I would draw 50, comma 60, so way up here. I'll label this, so this would be 40, comma 15. And I'll label this will be 50, comma 60. You guys see what I'm doing here? All right, cool, just making sure. Then I would apply that formula. But to me, when I graph it, like small kind of like this, I didn't graph every single point, but I just graphed 2 points. And you can choose any 2 points. Well, if I graphed it, then at least for me, it's easy for me to see the rise that I'm going to use. So my m is going to be the rise. What is the rise? How far up did I go? Tell me the numbers you would subtract if you guys don't want to subtract it in your heads.
45 height and 10 right.
Good. So what he was doing is he did 60 minus 15, right? That's how he got the rise, 45. And the run, obviously, is 50 minus 40, which is 10. You have to go across 10. Does that make sense to you? So I didn't have to worry about plugging it into this equation or whatever. Although technically you did use the equation.
Well, didn't he use the equation?
Yeah, exactly. I used the equation, but I just really understood the idea that it's rise over run.
Oh.
What I'm saying here is there's going to be a lot of equations that you have, all right? There's going to be equations like, all right, here's the equation we use. M equals y2 minus y1 over x2 minus x1. And you could take these numbers and plug them in and do that. To me, this makes sense as to why I subtracted 60 from 50, or 15 from 60. Does that make sense to you? Yeah, question.
Can you simplify?
Yeah, you can
Oh yes, I'm sorry. You would
by
simplify
5.
this. It would be 4.5.
Bradley's confused.
Yep.
You said do that again.
Okay.
Confused.
It's because you're doing two things. You should just do like either the graph or the equation.
All right. All right. No, that's fair.
So
1 second. Sorry.
okay, 50 minus 40.
Okay. What I'm saying here is there's a lot of equations that you're going to have to memorize. What I would rather you do instead of memorizing every single equation under the sun, by all means, memorize it. I'm fine with that. If that's your cup of tea, that's fine. For those of you who don't like equations, you can kind of look at it like a little bit graphically, and you would say, huh, I understand that I need to go up. You know, I need to subtract 60 minus 15 to get my rise, and I need to do 50 minus 40 to get my run, because I could see that in order to get here to here, I would have to go up by 45 and across by 10. Does that make sense to you? Do you understand why I'm showing you to you graphically? Although I'll be honest with you, this thing doesn't look like a line to me at all. I don't know why it did this. Huh. This cannot be a line.
Why is it not?
Well, look at this. I'll tell you why. Because all right, the slope that we calculated here is m is equal to 4.5. Agreed? Right? And I told you if it were a line, you could choose any two numbers. We could choose this number and this number. What's the rise? 5. What's the run? 10.
that's gonna be.
So what's the slope between this number and this number?
It's not constant.
0.5. It's not the same number. I mean, you can kind of see that, obviously, if you were to graph it. The next point would be here. Is this a line? That is a jacked up looking line if I ever saw one. And then we can even do this one. At 30, it's at negative 15 over here. So like maybe this even doesn't look like it's this is not a straight line. What were they thinking? What kind of table is this? You know what I would write on this table? I would say, man, you didn't even give me the graph of a line, or the table for a line. Why are you asking me to find the slope? It doesn't make any sense.
So is it an incorrect problem?
No, I'm doing it. This is problem number 2 from homework number 1. And
And it says straight lines.
So- yeah, it says, compute the slope of the following linear functions. I'm looking at that, I'm like, that's not even a linear function. Anyway, let's do the next one. I'll draw the graph, and I want you to tell me how to do it.
We're gonna blame it on the people who made that. Not you.
Yeah, that was me. All right. So let's see. Up here is 2,500, and over here there's 150. There's 200. There's 100. There's 50. Let's do this. And then this is 2. Okay, let's see. This would be 5, 10, 15, 20, 25. Good. So this would be 500, 10, 100, or 10,000. 100. This would be 1,500, 2,000. All right, and then the line looks like it goes from here. It's up here. I'm just kind of giving you graph paper right here. Okay, you guys are going downstairs already?
Yes.
All right. So it goes from here to about here. Tell you what, I have a meter stick. Let me grab that. Yo.
Is that Benjamin?
Yes, that's Benjamin.
Hello.
He's big now. Here we go. All right. Find the slope. Work together. Find the slope.
Okay.
How would you do that? How would you tell me as exact as you possibly can?
So let's change this.
You folks work very independently for saying when I say work together.
Does it cross on 2,500? The top.
It does cross at 2,500.
Zero.
And it crosses also at
I mean, that's
100,
zero.
but at 1,000, 200.
See, that's the part that I don't know. You're saying, oh, it crosses where?
The 100 and 1,000.
Yes, I would agree with you. I could definitely say it crosses through those grid lines, yes.
So just
So we can find it from there, right?
Yes. I was waiting for some of you folks to say it crosses right here. The hard part, you can't read that part of the graph, right? So you find a nice part where you can read. I mean, this is common stuff. When I teach you chemistry, which I'm going to be teaching more than half of you chemistry, you folks need to be able to do this kind of stuff. You'd be like, well, I can't really read this, but I can definitely read this part of the graph. We cool?
okay.
So, what 2 points are you planning to choose?
Zero,
100,
2,500.
0, 2,500,
and
and
100.
wait, she can say it.
100, 1,000.
100, 1,000. All right, someone find the slope for me, please. I think my son stole my cell phone.
So this would be negative. So it would be so it would it be negative 1? The y is going down.
All right, we're good. Did you guys calculate it? What is it?
Well, negative 1,500 over 100, but it's
Negative 1,500 over 100?
Yeah, but it's gonna be.
So it's negative 15.
Yeah, I got negative 15 too.
Perfect. And I'm glad the way you guys did that. In fact, the reason why I took the time to draw in all these grid lines is because I wanted you to realize that, hey, usually you choose this point and this point, but you choose the ones that kind of nicely cross these grid points right here. If you can see that it nicely hits that point right there, that's good practice to do. All right? Now, this goes into a little bit of chemistry because even if you're not taking chemistry from me, that would be you, Willa, and
me.
you, Lucas. Even if you're not taking chemistry from me, this is good practice for you to know because if you take physics from me, or if you take physics or chemistry or biology or any science from anybody, these kinds of techniques are important for you to be able to do. My hint is this. Whenever you're looking at a graph and you want to find the slope, always choose the points as far apart as you can. However, what supersedes that rule is if you can choose points that land nicely on points you can see, on grid lines you can see, choose those points. Okay? But try to choose it as far apart as possible. That will give you the most accurate representation of the slope. We cool? All right. Where did my paper go? There it is. Okay, so this is homework. Ah, there we go. Slope, line, intercept, form. Okay, so what equation do you know about slopes besides, or what equation do you know about lines besides just the slope? I'll tell you what, you folks look like you're getting restless because you're all loud and everything, so you guys need a break pretty soon? All right. What equation do you folks know about lines? Starts with a y. What is it?
Wow.
There we go. Y equals mx plus b. Awesome. What is the b?
That's
Y-intercept.
That would be the y-intercept, okay? Let's define the y-intercept. In the y-intercept, in fact, I taught Tejas back there, I taught him Algebra 1, and this is something he knows, right? If you want to find the y-intercept, what do? Do you remember? All right, let me ask everybody else then. If you want to find the y-intercept, what do?
The zero.
The zero what?
Like,
What are you talking about, the zero?
Y-axis.
Yeah.
That goes to zero.
You isolate it? Oh, no. Sophia's got it. You set the x equal to 0. If you want to find the y-intercept, you set x equal to 0. Because the y-intercept is defined as where the dang line crosses this axis right here, right? And I couldn't tell you exactly what number this is, but I can definitely tell you what the first coordinate of it is. What is that?
0.
Right, because this thing occurs at 0, comma, some number. What is that, Shaw? Oh, I get lunch. Awesome. All right, this occurs at 0, comma, some number, and we're going to call that number b. We cool? And in order to find b, the best way is to set x equal to 0. That is true whether we're dealing with lines or parabolas or cubic functions or circles or whatever. If you want to find the y-intercept, set x equal to 0. Got it? So that's the reason why I drilled that rule into my Algebra 1 kids. I'm drilling it into you now. By the way, if you want to find the x-intercept, what should you do?
With the
Set y equal to 0. If you want to find x-intercept, you set y equal to 0. If you want to find the y-intercept, you set x equal to 0. Just set the opposite the guy over to 0. We cool? All right. What is the m?
Slope.
We talked about this in ad nauseum. What is the m? You said it. I'm sorry. Slope. Exactly. It's a slope. Good. So your y equals mx plus b is the general form of a line. Anything of this form is a line. Is this a line? Y equals 1/3 x plus 2.
yes.
Okay? What about this form? What about 3y equals 2x plus 4? Is that a line?
I've seen one like that at least.
Yes, of course it is. It's just not in y equals mx plus b form. You just divide everything by 3, all right?
Yeah.
So this is y equals 2/3 x plus 4/3. Is that a line?
Yeah.
Yes, of course it's a line. Cool? What about this? Y equals 2x. Is that a line?
Yeah, that's
This looks like y is less than 2x.
Oh.
Y equals 2x. Is that a line?
Yeah.
What is the b in this case?
0.
0. What is the slope in this case?
2 over 1.
In fact, I asked you to graph this thing earlier. It looks like a line like this. Are we cool? All right, good. I'll tell you what, why don't you take your brains, we'll give you a 5-minute break, and we'll get back into this. I am on section 1.4 already of this packet right here. And I want to get to section,
kind of like a review.
well, this is all a review. It's called Algebra Review 1. So I think that for the next, almost until the end of the quarter, we're going to do Algebra Review 1, 2, 3, 4, and 5, where we're going to talk about lines, and then quadratics, and then, yeah, so this review package is for lines. All we're going to do today is lines. But I'm going to go through it quickly, if that's all right with you.
Yeah.
Cool? Because, I mean, I didn't want it to be boring, but at the same time, this is where we're at. So quarter 1 is pretty much review of Algebra 1. That doesn't mean that Algebra 2 is going to be, oh man, this is cake. Because the reason why I'm reviewing Algebra 1 is because I'm going to hit you folks so hard with Algebra 2 that you need to know your Algebra 1 like it's your ABCs. You need to know it like it's the back of your hand. That's why I'm spending so much time reviewing it. Sound fair?
Yeah.
And so that's why, I mean, the stuff we're learning now is we're gonna be building on top of really quickly. So keep up with it now while it's easier. Cool? All right, let me put the video on pause. We give you a 5-minute break and we'll be good. Here we go.
5-minute break.
All right, what up, folks? Let's get this party started. I'm on page 11 of the Algebra 1 packet. I just want to go quickly. That's why I printed out a copy for each of you. I have a question for you. Here's a tough one. Somebody tell me what the graph of this looks like right here. Y equals 2. You can describe it for me online.
Well, that would be
Just a straight line at
Yeah.
2, right?
Straight horizontal line at 2. Very good. Identify for me, what is B equal to? In this case.
So, it's the same thing, right?
Oh, 2.
Y, B is 2.
Yeah.
What is the M in this case?
There's no slope.
There is no slope. There must be a 0 in front of the slope because there's no x anywhere in this equation. Does that make sense? Because if I have the y equals mx plus b, do you see an x?
no.
It must have been gotten killed by the 0 in the slope. Hence, you just have y equals some number, and that number happens to be our b. Does that make sense?
So it'd be like a straight horizontal line across the whole plane. Y equals
Yeah, that's a trippy one. Cool?
Yeah.
All right. What is, all right, I guess I can't really trip you up now, but what does this graph look like?
That would be the same thing, except the horizontal line will be on -2.
We cool? Are you good? You sure? All right, you're not just giving me this?
Yeah.
We good? Cool.
Don't know what happened.
What do you mean what happened? No, what happened? Same for x, but it's a vertical line. I think what Sophia means is if I have
Y
something,
equals negative
if I have an
x.
equation like
Does that
x
look
equals 4, then yes, I agree with you, Sophia. This would be a vertical line
Are we on packet
at
1,
4.
2?
However, this has a slope of what? Infinity. It is not a function. It's a
So
line.
then all the x's
vertical
are
line.
undefined.
It's not a function. Because right over here, it doesn't pass the vertical line test. Cool? Willie, you look like you got a headache. Is it because of all this math that we have?
Thea says, what does y equals x, negative x look like?
What does y equal negative x look like? Let's try that. Y equal negative x. What does that look like?
It's all
Come
the
drop.
Wait, what?
What? Oh,
What, y equal negative x, what does that graph
all the
look like?
y's are negative 1x.
There we go. Would you agree with me that y equals negative x is the same as y equals negative 1x?
Yeah.
What is the slope? Negative 1. What is the b? 0. There is no b anywhere over here. We talked about what a slope of negative 1 would look like. Looks like that. This is just a little bit trippy because you don't see a number out in front, but if there's no number, you just assume that it's a 1. Right? You've done that before. Cool. All right, let's try this one. What is question 13 even asking? I don't even know. Or page 13 even asking. Let's take a look at it. If George the slug is traveling at a rate of 2 inches per minute, and we know how far he has traveled at time t, then 1 minute later, he will have traveled an extra 2 inches. Every linear function behaves in the same manner. Every 1 unit change will produce a change in the output equal to the slope. How do we write this in function notation? I don't often see it like this, but let's decode this. I'll tell you what. It said something like f of x plus 1 equals f of x plus m. Does that make sense to you? All right, let's talk about this because I think it was Emily who was asking me lots of questions about functional notation. It looks kind of crazy, right? This was yesterday you were asking. So if this were f of x, let's make it t instead. If this were f at 1 minute, or
It's not.
yeah,
It says Are you talking about the example 1?
Well, I'm just talking about decoding what this means. I don't understand what this means. They gave me an equation that said this is how it's modeled. And I'm like, what are you talking about? Actually, to be honest with you, I looked at it now and I'm like, oh, I get it. But you don't get it, right? So let's sit down and decode this thing together. This is f at t. What does this represent?
That would be plus 1 of t.
If this is f at time t, then what is this?
You're adding
1
1 over
the
2t.
Yeah, so it's not 2t, it's just,
T plus 1.
it's 1 minute later, right?
Yep.
And then why does that equal to m? Well, I think that what it's saying is, your slope is what? Rise over run, right? So if you start here, at some f of, or here's some t right here, right? Then right here would be t plus 1. Do you agree? If this were like 4, then this would be 5.
So that was just equal to f then.
So this would be f of t, and this would be f of t plus 1. When I have an f in front of it, it means I'm referring to this is a y value. This is the output. This is also an output. You guys see how this t is related to this f of t?
Yeah.
And you see how this t plus 1 is related to this f of t plus 1? And I think what this is saying is that your slope is really just this number minus this number, right? F of t plus 1 minus f of t is equal to f. But they didn't write it like that, they just put the f of t on the other side. So that's the equation that they came up with. Oh, okay, this makes sense to me.
Yeah.
Are we cool with that?
That's
It's written a little weird. I'll be honest with you, I don't often see it like this. But it makes sense to me. I can decode it at least. We cool? Alright. And I'll be honest with you, Mr. Daldy quite often plays an idiot. And I pretend like I don't know what I'm talking about. Because it provides me two great advantages. First advantage is quite often I really don't know what I'm talking about, but you guys don't know when I'm faking it. The second option, or the second reason, is because I play an idiot because what I do is I try to, I don't ever take things face value. I hate having teachers say, okay, here's the quadratic equation, memorize it. I'd rather take something and build it from scratch. I'd rather take something, oh, that looks weird, I don't understand it, and decode it for you. Because when you watch me build something or figure something out, that will help you build something and figure something out. Especially when you're hitting these tests like SATs and all of this kind of stuff, and you can't memorize every equation under the sun and that kind of stuff. I want you to take a look at it and understand the concept. So quite often I'll play an idiot and I'll just be like, I don't know what's going on. And I really do, so don't worry, don't freak out, don't think your teacher's an idiot. I'm actually really good at math, just letting you know. Vote of confidence for Mr. Daldy. Okay, so let's see. Suppose f of 1, whatever. Were you writing that
No,
down?
I found out where you.
Okay. Suppose f of 1 equals 50. And f of x plus 1 equals f of x plus 3. Find f of 2. Oh, okay. So this is that weird relation they gave us. So if I want to find f of 2, what should I plug in for x? I should plug in 2 here. So this would be f of 2 plus 1 equals f of 2
Yeah,
plus
x
3.
is greater than 1. So put in any number that is greater than 1.
I should put in any number. No. This will give me f of 3. I don't want f of 3. I want to figure out what f of 2 is. What should x be? X equals 1, okay, fine. This is f of 1 plus 1 equals f of 1 plus 3. 1 plus 1 is?
2.
Okay, so really they're saying if you want to find f of 2, take f of 1 and add 3. Right? What is f of 1?
50.
Whoa, 50, awesome. 50 plus 3. What is f of 2?
53.
53. Very good. Let's find, do they have f of 0? That looks pretty tough. Actually, you know what? I'll tell you what. What is the, let's find f of 0. Let's figure out what that is. If I want to find, how would I do that? You guys know? I'll tell you what, let's see if we can figure out a pattern. What is f of 3 equal to? F of 3 would be f of 2. It's f of 3 is the f below it plus 3. So what is f of 3? What's that? 150. What? No. Come on, folks.
2?
Huh? 2. 2?
I don't know. I just
All right, you're saying x equals 2? Is that what you mean? You're like, yeah, no, that's not what I was saying, but yeah. All right, you're right. If x equals 2, then I would have f of 3 equals f of 2 plus 3, right? Do we know what f of 2 is?
Yes.
It's what?
It's 53.
It's 53. So what's 53 plus 3? 56. Do you see a pattern going on here? What is f of 4?
It's going to be 59.
59. Do you folks see a pattern here?
Yeah.
Okay. Judging from that pattern, what is f of 0?
47.
47. Are we cool with that?
Well, at least this is now linear.
All right. Well, we know it's linear. How do you know it's linear?
Because it's on the same, you just add 3 every time.
Because every time you go across, it goes up by
3.
3. So I go 1 across, up 3. 1 across, up 3. Or maybe rise over run should probably say 1 up 3, 1 across, up 3, 1 across. Does that make sense? All right. So I got a question for you. What is the, if I were to write this as, I hate this notation. This is weird for me. This is something new for you, right? If I were to write this as y equals mx plus b, how would I do that? Do you know? You could spout for me the equation. Equals what? Occasion, try not to look like you're going to die.
Y equals.
You okay?
Okay.
So f of x is y. So you put y into m.
What's
f of
m?
0. You put f of 0 into.
What's the slope?
3.
3. 3x. We're getting somewhere.
And
What's
then
b?
47.
47.
Yeah.
In order to find the b, what is b?
Y.
It's the y-intercept. If I want to find the y-intercept, what do I do?
X equals 0.
X equals 0. Look, x equals 0. It's 47. So this right here, with these two pieces of information right here, it's a secret code for 3x plus 47. And you think, man, why didn't you just write 3x plus 47 in the first place? And I'll be like, well, because we want to confuse you. No, because we want to get you folks good at decoding this kind of information. Because believe it or not, things come in this form right here kind of often. Are we cool? I like that. That one was a new concept. I didn't see that before. I don't think that people tried that one before. All right, so that should take you up to 1.4. And I'll tell you what, we don't have time to go through that because we're going to finish. Thank you very much for coming to my Algebra 2 class. I am not going to be holding a big blue button session for algebra or for chemistry class. I will, however, record something for all of you chemistry people I'm going to be doing a lab with the chemistry people right here. I will, however, be recording something special for all of you online, our chemistry people, and posting it up to the website. Sound good? That is the advantage of coming in. I'm not holding a chemistry class. All right, the reason being is this. It's too stressful for me and any other science teacher we've found for us to try to sing and dance in front of a camera while we're holding a chemistry lab. So, Bradley, you're going to have to email me that chem question. I won't be able to get it to it now. I've got 5 minutes to set up my chemistry lab. You need help with conversions. All right, that's a math question more. Email me the question. I'll make a separate YouTube video just for you, and then I'll post it up to the whole class so that everyone can see. Cool? All right, talk to you later. Stop the video.